Hello everyone, I'm Jian Jun. I will present our paper, Assessing Attendance by Peer Information. Class attendance is an important information on the student. From the attendance data, we can understand the attainment and study motivation, the academic performance, and even the psychological well-being, such as the depression status. To get the accurate information, it is necessary to compare the attendance fairly. However, in a university, two students in the same cohort can have very different course registrations. Courses can have different attendance policy as well. Courses with mandatory attendance requirements usually have a higher attendance rate than those do not. Finally, online courses are easier to attend than offline courses, which can lead to higher attendance rates. Traditionally, class attendance is measured in an isolated way. The attendance of a student is only about the student, limited to one or few courses, and have nothing to do with other students. With the advancement of technology, it is now possible to measure the attendance in a campus-wide scale. We can measure the attendance of all courses and all students. The additional peer information can help improving the attendance measurements. In our method, we introduce the peer information to attendance by considering the attendance of other students. We will measure the contribution of each student to the attendance rate of the class. Our method can compare attendance in a fairer way. In addition, the new measure can provide some hints on students' academic interests. For example, if a student has a high attendance rate in a class that has an average low attendance rate, that indicates the student could have a stronger interest in the class than other students. The new attendance calculation goes in this way. First, we calculate the attendance rate of a class, RC, which is the number of attended students divided by the number of registered students. Then we calculate the attendance contribution of a student. If a student attended the class, then the value is 1 minus RC. If the student did not attend the class, the value is negative RC. Finally, the relative attendance index of the student, as denoted as RAI, is the average attendance contribution over all registered classes of the student. RAI is a value between -1 and 1. 1 is the best attendance, and -1 is the worst attendance. The new attendance measurement can alleviate the effects of the problems we mentioned before. For courses with mandatory attendance requirements, their attendance rates are high, so that students' attendance contributions are low, which will lower their REI values, and this is fair. Since REI can better reflect the engagement of students, we can compare students with different registrations. Finally, REI is adapted to the attendance level. Therefore, it can be applied to compare the attendance of online and offline courses. In our experiments, we calculate campus-wide attendance data based on Wi-Fi usage. The attendance values were then converted into REI. Please note that REI is a general method and can be applied to other attendance data such as those calculated using QR code. The university where we collected the data has no attendance requirements. However, classes can have their own attendance requirements or have in-class quizzes to encourage attendance. The data are from 4,000 students and 40,000 courses in 37 categories. Experiment result shows that the new measure, RAI, outperforms the traditional attendance rate, denoted as AR. RAI has a better overall Pearson correlation with GPA. When decomposed into course categories, RAI is better than AR on 73% of the categories. With only 8% of the course category, RAI is worse than AR. We observed that courses with mandatory attendance requirements, such as language courses, usually have a relatively low correlation with GPA. The new measure can be used to study students' academic interests. For this purpose, we perform clustering on attendance data. We apply the DB scan algorithm and select the best parameters using the silhouette score. We apply the same procedure to RAI and AR. AR failed to generate a meaningful clustering result. Everything is merged into one cluster. RAI generates a result with 8 clusters of reasonable sizes. This slide shows the RAI clustering result. The clusters are in 8 different colors. For each cluster, we show the top 5 majors with the largest number of students. The figure shows the RAI levels of the 8 clusters and their majors. We can see that the cluster in orange has the worst RAI values. The figure on the bottom shows the corresponding ratio of students' GPA being in the last 10% of their majors. We can see that the orange cluster has the worst last 10% ratio. One interesting phenomenon is that within each cluster, the major with the highest RAI value has the lowest last 10% ratio. There is only one exception though. In the second cluster, the major with the lowest last 10% ratio has the second highest RAI value. The highest RAI major is bioinformatics, which is a new major and has a relatively small enrollment. When students select majors or switching majors, this result can help them to reduce the probability of getting low performance. In our experiments, we use Wi-Fi-based methods to collect attendance data. It is possible that some students close Wi-Fi or even their cell phones before going to the classroom. However, comparison with attendance sheets shows that the attendance data is accurate. We conjecture 2 reasons behind it. First, in the university of this study, usage of laptops and tablets in the classroom is popular. All these devices are included when calculating attendance. Secondly, many students in this university also have the habit of checking news or social media before and after class. It is interesting to see how RAI performs on attendance data collected using other methods, such as QR code. Thank you.